So continuing where we left off, looking at this question here, C. Gwen starts work at the age of 21 and plans to have $1 million saved by the time she retires. She regularly deposits 139 per month into an account paying 4.5 compounded monthly. How long does it take for her to reach 105,577? So this one here, we can instantly see that the question's asking for how long. So that's the time period. So therefore, we have to be finding n. We just fill in the rest of the values. It's 4.5%. Obviously, at the age of 21, we're not starting with any money in the bank account, so that's just zero. We're putting $139.03 in every month, so that just stays as the regular payment there. The future value, remember to have this as a negative, is 105,577.46, because that's the savings goal, and everything is done monthly, compounded, and payments are done monthly. So when you have a look at your values here, you can see that n gives you a value of 360. Now remember that we're making the regular payments in months, so the final value is, it will take her 360 months, or if you just divide that by 12, you'll get 30 years. The next part to this is she adjusts her payments, and when she retires, she has $1 million in the superannuation fund. She now wants to receive monthly payments for 20 years. She has secured an interest rate of 3.25% compounded monthly. What will the size of her monthly payments be? So this one here we're looking at, we've got 20 years through monthly payments, so 20 times 12, which would be 240. You've also got 3.25%, which is your investment rate. Next, you've got the $1 million as present value, and then you've also got the PMT, which is your question mark. That's what we're trying to find. So what's the size of the payment's going to be if you want money to last for 20 years? Future values, you're going to expect to have $0 in your bank account at the end of that time. And then you've got still compounded and monthly is coming out monthly, so 12 and 12. So when you get your PMT value here of 5,671.96, that's what you should be able to withdraw over the next 20 years per month to live on. So next question, after 6 years, she needs to withdraw a lump sum of $56,000. She withdraws $56,000. How much longer will her savings last if she's still making the regular payment withdrawals of $56,000? So the way to do this one is there's two ways to do it. Basically, the first one is we need to find out how much is left in the balance after 6 years. After 6 years. So 6 times 12 is your n, 3.25. You've got $1 million, and then you've got the negative here, which you're minusing the value from that you're taking out per month. Future value is obviously what you've got, what we're trying to find, and you've got 12 and 12. To be honest, this one's probably the easier way to do it than the PM1, PM2 values. So you'll get your answer here as a future value of 764,744.02. From there, though, that becomes our new PV value, as you can see. So a new PV value is that value there. And what we're doing is we want to see how long her money is going to last. So that's our new n value, is the question mark. We minus the 56,000 from the original PV value of what we had left in the bank account, and it gives us 708,744.02. So you again find your n, and you'll get an n of 152.76. So her money will last 152 months, or 12.73 years if you divide that by 12. Now remember as well, her money did last 6 years before that too, so it did last 18.73 years. So really, withdrawing that 56,000 only lost a year and a little bit, but yeah, so it did kind of reduce it a little bit, but not quite as much as you would think. The next one here, Deborah buys a house and borrows $175,000 at 6.1% over 25 years interest. Payments compounded monthly. in the first 4 years how much interest is paid on the loan. The best way to do this one here is you just find your PMT value first. So you sub in all your values, find out what the regular payments are. So the regular payments are 3,104.13. So we've done that quite a few times, that sort of skill. Now the next one is that you want to find the total interest paid on the loan. So the easiest way to do that is to use the sum interest button on the AMT section of your calculator. So that's where you'll find the PM1 and PM2. Now we only want to find the PM1 is always 1 because it's always the first period of payments. PM2 is the last periods of those payments. So the last period is after the 4 years, which is paid monthly. So 4 times 12, which is 48. The rest of the values stay the same, and then you need to hit this what means sum, so it's the sum of all the interest paid. So the total interest you've paid is $112,655.50. So you've paid quite a bit over 4 years of interest on the account, and really you haven't actually paid too much of the loan itself. Now the question is not asking for the balance, but we're going to need it for the next question. So if you press on BAL in the same section of the calculator, it will tell you how much left you have to pay off the mortgage that you've taken out. So out of the 475,000, you only have 438,675 left to pay. The rest of the money that you've paid is being paid off, is being paid in interest. That value just there. So a total of that much is being paid in interest after 4 years, and that's how much is left to pay in the bank account. Now, after 4 years, the interest rate rises to 8.25%. Find the new monthly that needs to be paid off for the loan. So the loan's going to jump up in value, obviously because of the higher interest rate. So what you need to do is that this is after 4 years. So basically minus your 300 from 48 periods that you've already paid for the first 4 months off the 300, and you'll get 252 left. From there, you need to find the I value, which is, oh no, sorry, not need to find it, but you need to replace it with 8.25%. Your PV value becomes the value after the 4 years, so that is the 438,657.13. So that's your PV, and then you find your new PMT. So the PMT is going to rise to 3,668.34 payments per month. Now the next question, using the original loan repayments, demonstrate how Deborah fortnightly payments can save her time and money. You need to set the calculator. Now the first part of this with the monthly payments, we've already done this. So this is in part A, we've already found the monthly payments are $3,104. So we just need to find the fortnightly payments now. So the only things that we need to change are your end value. So obviously it's not, we're not making the payment periods monthly anymore, it's fortnightly. So that's 26. And also we need to change our PY, so that's the payment period. So that also needs to change to 26. So we find our PMT, which will give us $1,430. So that's how much we need to pay every fortnight. So from there, we can just work out, well, how much we're actually paying over 1 year, say, because this would give us an indicator if we're saving any money. So initially from question A, we've got the $3,104 paid monthly, so you just times it by 12 to get into years. So this is how much money we're paying in the loan per year, which is $37,249. If we times the fortnight that we've just found, the PMT, which is 1,430, by the 26 fortnights per year, then our yearly payments are going to be $37,198.46. So that's a saving of $51 per year. So not a huge saving, but it is a bit of a saving. And over the 30 years, it might add up to a little bit of money. The next part to this is why have the regular payments been simplified? What have we done to the loan? The regular payments, should be from monthly to fortnightly, but basically the fortnightly is compounding earlier than the monthly, so it's building that, it's not compounding as much interest on the loan itself because we're paying it off quicker. Our money's coming in at a more steady closer intervals, so it's not compounding over larger periods of time. So the compound interest over that period there doesn't add up quite as much. So that's why if you reduce the term, so if you even paid daily, you'd be saving more money as well. Now, question 4, we've got Arthur needs to borrow some money to expand his business. He decides that a sinking fund may be a good option. The loan is for $100,000 over 4 years. We need to set up a fund to be able to do this. So the rate is 7.25% with the sinking fund rate of 6.6. So the first thing you need to do with this question here is just work out how much money is going to be paid in interest. So how much will this cost Arthur over the 4 years? And basically, over the 4 years, what we've got is $100,000 times 7.25% times 4 years. So divide that by 100 and we'll find that the total amount of interest we've paid is $29,000. And then the next part to this is we need to find the PMT payments and work out how much this will cost Arthur over the 4 years. So we've got the end time 4 times 12, 48. The sinking fund is 6.6%. So this is the money that you're putting into the sinking fund itself. Your future value is we want to have $100,000 at the end of it. Now our PMT we're putting in is $18,026.11. So basically the loan that we have to pay of interest, and this is just solely the interest payment is the first part of this. So we're paying $29,000 solely in interest. That's not paying off any of the loan. However, in the separate fund we're putting money into to build up to that $29,000 is missing the equal sign, but it's this value here of $87,653.28. Now, as you'll notice, that's a bit less than the $100,000 that we've initially taken out for the loan. The reason that is because we're putting money into this account, so this account's earning interest. So we earned about $12,500 in interest. So that's reduced how much we've had to pay on the loan a little bit. So the total cost on our loan isn't really the $100,000 plus the $29,000 in interest. It's a bit less than that. So it's $116,653.28. So we've actually reduced it by having a sinking fund as well. So calculate the book debt after 2 years. 2 ways to do this. You can do the PMT1 and PMT2. Your PMT2 will just be 24 as well, and you'll press the BAL button, so the BAL, which will give you the balance after the 2 years, and that'll probably be the easier way to do it. This way is a little bit, just got one more step in it, but basically we're finding the book debts after 2 years. So we need to find the future value. We've started with $0. We're putting $1,826 into the account. So at the end of it, we're going to have $46,713 in the account. So the book debt means how much do we still have to pay, and we still need to save, if you just minus it from the $100,000, still need to save $53,286 over the next 2 years. Now the last question is just the effective rate of interest. So you've got 2 accounts. One account is paying with an establishment fee of $800 and a monthly fee of $750 at a rate of 4.4%, and the second account is 4.1%. We're assuming that it's compounded monthly, and it's $250 with a $250 yearly fee. So basically with this one here, we just set the question up the way that all the details have been given. So we've taken out a $320,000 loan. Now the way that we add our values onto it is we add on the $800 for the first account, and then we add on the monthly fees, which is 7.5 times 300, because there's 300 periods. So really on our loan, we're actually paying $323,050 on that loan, not the $320,000. Reason being is because the establishment fees and the cost to keep the bank account running. So find your PMT. Once you got your PMT, you need to reset your PV value back to 32,000, and then you press I, which will find the effective rate of interest. So the effective rate of interest will be slightly more than what the initial rate of interest was. So instead of being 4.4 as they've advertised, because you have to pay to keep the account open, the effective rate of interest is actually 4.49%. So that's the first account. The second account is, again, we're just adding on our monthly fees. So it's 320,000, put in your new values here, plus 250 establishment fee, and then 250 yearly fee. So only times this one by 25 because we're only doing it yearly. So for 25 years, and we get $326,500. From there, you find your PMT and reset your PV value again back to 320. And then from there, you just you find I, and I will give you the value of 4.29. So even though the advertising 4.1, it's actually 4.29% effective rate of interest once you add on your account fees and things like that. However, account 2 is still providing the best account because it does have a lower rate of interest. So this one's probably the better go in the end. So I think that's all for the test. And yeah, I hope you've learned something along the way.